West African cuisine and history. West African peoples were trading with the Arab world centuries before the influence of Europeans. Spices such as cinnamon were introduced and became part of the local culinary traditions. Centuries later, European explorers and slave traders influenced regional cuisines to a limited extent. European merchant and slave ships brought chili peppers and tomatoes from the New World to West Africa, and both became ubiquitous components of West African cuisines, along with peanuts, maize, cassava, and plantains. In turn, these slave ships carried African ingredients to the New World, including black-eyed peas and okra. Around the time of the colonial period, particularly during the scramble for Africa, the European settlers defined colonial borders without regard to pre-existing borders, territories, or cultural differences. This bisected tribes and created colonies with varying culinary styles. As a result, it is difficult to sharply define, for example, Senegalese cuisine. Although the European colonists brought many new ingredients to the African continent, they had relatively little impact on the way people cook in West Africa. Architecture of Africa. Like other aspects of the culture of Africa, the architecture of Africa is exceptionally diverse. Throughout the history of Africa, Africans have developed their own local architectural traditions. In some cases, broader regional styles can be identified, such as the Sudano-Sahelian architecture of West Africa. A common theme in traditional African architecture is the use of fractal scaling. Small parts of the structure tend to look similar to larger parts, such as a circular village made of circular houses. African architecture in some areas has been influenced by external cultures for centuries. According to available evidence, Western architecture has influenced coastal areas since the late 15th century and is now an important source of inspiration for many larger buildings, particularly in major cities. African architecture uses a wide range of materials, including thatch, stick, wood, mud brick, rammed earth, and stone. These material preferences vary by region. North Africa for stone and rammed earth, the Horn of Africa for stone and mortar, West Africa for mud, adobe, Central Africa for thatch, wood, and more perishable materials, Southeast and Southern Africa for stone and thatch, wood. Author Binyavanga Wainaina argues that people from the West would portray Africa as a decrepit and barren land, and had failed to look at the wonders of the continent. History of science and technology in Africa. Africa has the world's oldest record of human technological achievement, the oldest surviving stone tools in the world have been found in Eastern Africa, and later evidence for tool production by humans' hominin ancestors has been found across West, Central, Eastern, and Southern Africa. The history of science and technology in Africa since then has, however, received relatively little attention compared to other regions of the world. Despite notable African developments in mathematics, metallurgy, architecture, and other fields. Military history of Africa. Military history is the study of armed conflict in the history of humanity and its impact on the societies, cultures, and economies thereof, as well as the resulting changes to local and international relationships. The military history of Africa is one of the oldest military histories in the world. Africa is a continent of many regions with diverse populations speaking thousands of different languages and practicing an array of cultures and religions. These differences have also been the source of much conflict for millennia. Like the history of Africa, military history on the continent is often divided by region. North Africa was part of the Mediterranean cultures and was integral to the military history of classical antiquity, and East Africa has historically had various states which have often warred with some of the world's most powerful. The military history of modern Africa may be divided into three broad time periods: pre-colonial, colonial, and post-colonial. Genetic history of West Africa. The genetic history of West Africa encompasses the genetic history of the people of West Africa. The Sahara served as a trans-regional passageway and place of dwelling for people in Africa during various humid phases and periods throughout the history of Africa. Archaic human DNA. According to a 2020 study by Durvasula et al., there are indications that 2% to 19, or about 6.6 and 7.8 of the DNA of 4 West African populations may have come from an unknown archaic hominin, which split from the ancestor of humans and Neanderthals between 360s Kaya to 1.02 Manya. It also suggests that at least part of this archaic admixture is also present in Eurasians, non-Africans, and that the admixture event or events range from 0 to 124 kbp, which includes the period before the out-of-Africa migration and prior to the African-Eurasian split, thus affecting in part the common ancestors of both Africans and Eurasians, non-Africans. Archaic traits found in human fossils of West Africa, e.g., Iho-Eleru fossils, which dates to 13,000 BP, and Central Africa, e.g., Ishango fossils, which dates between 25,000 BP and 20,000 BP, may have developed as a result of admixture between archaic humans and modern humans, or may be evidence of late persisting early modern humans. While Denisovan and Neanderthal ancestry in non-Africans outside of Africa are more certain, archaic human ancestry in Africans is less certain and is too early to be established with certainty. Ancient DNA. As of 2017, human ancient DNA has not been forthcoming in the region of West Africa. The Tafaralts of Morocco, who have been radiocarbon dated between 15,100 cal BP and 13,100 cal BP, and were found to be 63.8 Natufian, were also found to be 36 for sub-Saharan African, Itaji Hadza, which is drawn out most of all by West Africans, Watigo Yoruba Mende. In addition to having similarity with the remnant of a more basal sub-Saharan African lineage, Hega, a basal West African lineage shared between Yoruba and Mende peoples. The sub-Saharan African DNA in the Tafaralt people of the Ibero-Mauritian culture may be best represented by modern West Africans, Yoshigas Yoruba. West African hunter-gatherers in the region of Western Central Africa, Ajay, Shumlaka, Cameroon, particularly between 8,000 BP and 3,000 BP, were found to be related to modern Central African hunter-gatherers, e.g. Baka, Bekola, Biaka, Bedzan. In 4,000 BP, or even earlier during the Mesolithic, there may have been a population that traversed from Africa, e.g. to West Africa or West Central Africa, through the Strait of Gibraltar, into the Iberian Peninsula, where admixing between Africans and Iberians, Iodoi, of northern Portugal, of southern Spain occurred. Based on a small trace presence of sub-Saharan African components in select samples from Iberia and the discovery of a mitogenome L2A1 found in one individual, while all others belong to European mitochondrial haplogroups. In Granada, a Muslim, Mu'ur, of the Cordoba Caliphate, who was of haplogroups E1b1A1 and H1P6189, as well as estimated to date between 900 CE and 1000 CE, and a Morisco, who was of haplogroup L2E1, as well as estimated to date between 1500 CE and 1600 CE, were both found to be of sub-Saharan West African, i.e. Gambian, and Liberian descent. Y chromosomal DNA. DNA haplogroups in populations of sub-Saharan Africa. 8 males from Guinea-Bissau, 2 from Niger, 1 from Mali, and 1 from Cabo Verde carried haplogroup A1A. As haplogroup D0, a basal branch of haplogroup DE was found in 3 Nigerian men. Haplogroup DE may have originated in Africa. As of 19,000 years ago, Africans bearing haplogroup E1B1A likely traversed across the Sahara, from east to west. E1B1M2 likely originated in West Africa or Central Africa. Due to the large numbers of West Africans enslaved in the Atlantic slave trade, most African Americans, Afro-Latin Americans, and Afro-Caribbean people are likely to have mixed ancestry from different regions of Western Africa. 60% of African Americans in the study were of the E1B1A haplogroup, within which 22.9% were particularly of the EM2 haplogroup. They also possessed numerous SNPs, e.g. U175, U209, U1E1, U290, U14, U1Y6, and U2. Mitochondrial DNA, haplogroup L2 mtDNA, map of early diversification of modern humans, with haplogroup L2 entering West Africa. Studies of human mitochondrial DNA suggest that all humans share common ancestors from Africa, originated in the southwestern regions near the coastal border of Namibia and Angola at the approximate coordinates 12.5 E, 17.5 with a divergence in the migration path around 37 E, 2022 near the Red Sea. A particular haplogroup of DNA, L2, evolved between 87,000 and 107,000 years ago, or approx. 90,000 YBP. Its age and widespread distribution and diversity across the continent makes its exact origin point within Africa difficult to trace with any confidence. An origin for several L2 groups in West or Central Africa seems likely, with the highest diversity in West Africa. Most of its subclades are largely confined to West and Western Central Africa. Between 75,000 BP and 60,000 BP, Africans bearing haplogroup L3 emerged in East Africa and eventually migrated into and became present in modern West Africans, Central Africans, and non-Africans. During the early period of the Holocene, 50% of sub-Saharan African mitochondrial DNA was introduced into North Africa by West Africans, and the other 50% was introduced by East Africans. During the modern period, a greater number of West Africans introduced sub-Saharan African mitochondrial DNA into North Africa than East Africans. During the early period of the Holocene, sub-Saharan African mitochondrial DNA was introduced into Europe, mostly in Iberia. West Africans probably migrated across Sahelian Africa, North Africa, and the Strait of Gibraltar into Europe and introduced 60 of sub-Saharan African mitochondrial DNA. During the modern period, West Africans introduced 7% of sub-Saharan African mitochondrial DNA into Liberia and other parts of Europe, possibly by sea voyage. Around 18,000 BP, Mende people, along with Gambian peoples, grew in population size. In 15,000 BP, Niger-Congo speakers may have migrated from the Sahelian region of West Africa along the Senegal River and introduced haplogroup L2A1 into North Africa, resulting in modern Mauritanian peoples and Berbers of Tunisia inheriting it. Between 15,000 and 7,000 of sub-Saharan African mitochondrial DNA was introduced into Southwest Asia by East Africans, largely in the region of Arabia, which constitute 50% of sub-Saharan African mitochondrial DNA in modern Southwest Asia. In the modern period, 68% of sub-Saharan African mitochondrial DNA was introduced by East Africans, and 22% was introduced by West Africans, which constitutes 50% of sub-Saharan African mitochondrial DNA in modern Southwest Asia. Between 11,000 BP and 10,000 BP, Yoruba people and Asan people grew in population size. As early as 11,000 years ago, sub-Saharan West Africans bearing macro haplogroup L, e.g. L1B1A11, L1B1A6A, L1B1I, L1B1An, L2A1KL, may have migrated through North Africa and into Europe, mostly into southern Europe, e.g. Iberia. Amid the Holocene, including the Holocene climate optimum in 8000 BP, Africans bearing haplogroup L2 spread within West Africa, and Africans bearing haplogroup L3 spread within East Africa. As the largest migration since the out of Africa. Migration from sub-Saharan Africa toward North Africa occurred by West Africans, Central Africans, and East Africans, resulting in migrations into Europe and Asia. Consequently, sub-Saharan African mitochondrial DNA was introduced into Europe and Asia. Autosomal DNA. During the early period of the Holocene, in 9000 BP, Khoisan-related peoples mixed with the ancestors of the Igbo people, possibly in the Western Sahara. Between 2000 BP and 1500 BP, Nilo-Saharan speakers may have migrated across the Sahel, from East Africa into West Africa, and mixed with Niger-Congo-speaking Beram people. In 710 CE, West African-related populations, e.g., Niger-Congo-speaking Beram people, Bantu speakers, and East African-related populations, Nilo-Saharan-speaking Ethiopians, Nilo-Saharan-speaking Chadians, admixed with one another in northern Nigeria and northern Cameroon. Medical DNA, the genomes of Africans commonly found to undergo adaptation, are regulatory DNA, and many cases of adaptation found among Africans relate to diet, physiology, and evolutionary pressures from pathogens. Throughout sub-Saharan Africa, genetic adaptation, for mutation, Duffy blood group, increased rates of GSPD deficiency, sickle cell disease, to malaria has been found among sub-Saharan Africans, which may have initially developed in 7300 BP. Sub-Saharan Africans have more than 90% of the Duffy null genotype, pediculus. During the Copper Age and early Islamic era of ancient Israel, West Africans may have migrated into ancient Israel and introduced head louse from West Africa. Sickle cells. Amid the Green Sahara, the mutation for sickle cells originated in the Sahara or in the northwest forest region of western Central Africa, e.g. Cameroon, by at least 700 years ago, though possibly as early as 22,000 years ago. The ancestral sickle cell haplotype to modern haplotypes, e.g. Cameroon, Central African Republic, and Benin Senegal haplotypes, may have first arose in the ancestors of modern West Africans, bearing haplogroups E1b1a1L485 and E1d1a1U115, or their ancestral haplogroup E1b1on4732. West Africans, e.g. Yoruba and Isa of Nigeria, bearing the Benin sickle cell haplotype, may have migrated through the northeastern region of Africa into the western region of Arabia. West Africans, e.g. Mendi of Sierra Leone, bearing the Senegal sickle cell haplotype, may have migrated into Mauritania, 77% modern rate of occurrence, and Senegal, 100. They may also have migrated across the Sahara, into North Africa, and from North Africa, into southern Europe, Turkey, and a region near northern Iraq and southern Turkey. Some may have migrated and introduced the Senegal and Benin sickle cell haplotypes into Basra, Iraq, where both occur equally. West Africans bearing the Benin sickle cell haplotype may have migrated into the northern region of Iraq, 69.5%, Jordan, 80%, Lebanon, 73%, Oman, 52.1%, and Egypt, 80.8%, schistosomes, according to Steverding, 20. While not definite, near the African Great Lakes, schistosomes, e.g. S. mansoni, S. hematobium, underwent evolution. Subsequently, there was an expansion alongside the Nile River. From Egypt, the presence of schistosomes may have expanded via migratory Yoruba people into Western Africa. Thereafter, schistosomes may have expanded via migratory Bantu peoples into the rest of sub-Saharan Africa, Anjija, Southern Africa, Central Africa. Thalassemia. through pathways taken by caravan or via travel amid the Almoravid period. A population, Titike sub-Saharan West Africans, may have introduced the 29 ASG Vua thalassemia mutation, found in notable amounts among African Americans, into the North African region of Morocco. Domesticated animal DNA. While the Niger-Congo migration may have been from West Africa into Kordofan, possibly from Kordofan, Sudan, Niger-Congo speakers accompanied by undomesticated helmeted guinea fowls may have traversed into West Africa, domesticated the helmeted
Guinea fowls by 3000 BCE and via the Bantu expansion traversed into other parts of sub-Saharan Africa, e.g. Central Africa, East Africa, Southern Africa. West Africa's story is not just one of ancient empires and forgotten kingdoms. It's a story of resilience, innovation, and legacy that still shapes the world today. From the golden age of Mali and Songhai to the fearless warriors of Dahomey, these histories remind us that Africa has always been a land of greatness. But this is just the beginning. There are still so many hidden stories waiting to be uncovered, tales of courage, betrayal, and legendary leaders who changed the course of history. So what do you think was the most fascinating part of West Africa's history? Drop your thoughts in the comments below. If you love this journey, don't forget to like, subscribe, and hit the bell icon, because we have even more incredible stories coming your way. Until next time, stay curious, stay inspired, and keep exploring history. West Africa's rich heritage shapes the modern world in areas like art, music, and literature. Understanding this vibrant past not only deepens our perspective of global history, but also honors the enduring contributions West Africans have made to humanity. Take a deeper dive into the fascinating past of West Africa. Don't forget to like, share, and subscribe for more videos that blend academic insight with engaging storytelling, because history deserves to inspire us all.